Welcome back. So this is just going to be a real quick review of the antiderivative that we talked about on Thursday. Remember that the antiderivative is simply taking the reverse or undoing the derivative. And the definition is a function capital F of x is an antiderivative of f on the interval if the derivative of the antiderivative gives you the function for all x in the interval. And as we talked about on Thursday, if you take the antiderivative of a function, you can always just add any constant to the end. And because when you take the derivative, that constant will go to 0, you will be right back at f of x. There's an unlimited amount of antiderivatives. It just depends which one you pick. So I had told you this represents sort of all of them. They are called a family of functions, and we will explore that a little bit more in chapter 6, but for now that's the antiderivative. So how do you work with this? Well, one of the shortcuts we came up with on Thursday was simply to do the reverse of a derivative. Instead of subtracting one, we are going to add one to that exponent, and then we are going to multiply by the I forgot the reciprocal. I should say reciprocal. Of the resulting exponent. So let's kind of work a few and see how this goes. So remember, the derivative of the antiderivative should give you the function, and that's what makes f of x, capital F of x, the antiderivative. So we start here with the first function. We have 5x to the fourth plus 3x squared. So what we'll do here to this power is we'll go ahead and add 1. And the result is going to be x to the fifth power. And there was already a 5. I'm just going to keep it there. And we're going to multiply by the reciprocal of that power that we ended up with, which is 1/5. And you're going to notice that it reduces to 1. So this term itself will become x to the fifth power. Some of you might have just thought about it logically. If we add 1, it's the power is 5, and of course if we take the derivative of that, you would get 5x to the fourth. Alright, let's go ahead and add 1 to this one, so that will give us a 3. So we'll get a 3 is already there, x to the third power. Now multiply by the reciprocal of the power that you ended up with, which is 1/3. That of course reduces and you get x cubed. So the antiderivative, or one of the antiderivatives, you can just say that's capital F of x. And there's the first example. I will say that you can add any constant you want, because when you take the derivative of this function, the derivative of the antiderivative would be 5x to the fourth, 5x to the fourth, 3x to the second power, 3x to the second power, and it checks. So you can always check to see if you did it correctly by taking its derivative. I'm going to go ahead and pause and see if you can work out the next two. And you can do the same, pause the video, work them out, and then come back and compare with me to see the results. Okay, so I'm back. As you can see here, I add 1 to the power and multiply by the reciprocal. Keeping in mind you already have a coefficient of 6, so that is going to reduce to 2. And this one did not have a coefficient. Well, it did, it's a 1. But when I multiply by the reciprocal, it's still 1/2. And again, if you take the derivative of 2x cubed, you would have gotten 6x squared, and the derivative of x squared would of course been, oops, sorry, I forgot my 1/2 here. If I have my 1/2, that would have been 1x, and that's what we started with. So you just got to make sure that it always works out that way. In the next one, I add 1. Now notice I already had a fraction here, and that's okay. I just keep my 2/3. So I add 1 to the power and multiply by the reciprocal of that power. This becomes 2/9. There it is. 5, keep it there. Add 1 to the power. That gives me a power of 2. Multiply by the reciprocal, 5/2. And lastly, this 8. Technically, this 8 is 8x to the 0 power. So when you add 1, you end up with x to the 1 power times the reciprocal 8. So I end up with this function at the end. This is my antiderivative by using that shortcut, which is add 1 to the power, multiply by the reciprocal of the resulting exponent. And don't forget, you got to keep that coefficient. So sometimes it's a little bit easier, or you just kind of have to think through it. With trig, it happens that way. So we have the function is equal to cosine of x, so you have to think, all right, what was the function that when I take its derivative gives me cosine? And you probably guessed it, it is sine. So put sine of x. Okay, the derivative of sine is cosine, so it checks. Here, a little more interesting, it's a composite function, so I have cosine of 3x. I know that the antiderivative of cosine, of course, is going to be sine, but I have to keep the 3x in there. But I have to think to myself, if I take the derivative of sine of 3x, the result is going to be cosine of 3x times 3. But I don't want to have a times 3 because the function didn't have a times 3. It had a times 1. The coefficient was 1, not 3. So one of the things I can do to my antiderivative is multiply it by 1/3. Because I know the derivative of sine of 3x will be cosine of 3x times the derivative of the inside, which is chain rule. It would be times 3, but I already have a 1/3, so that'll divide out and give me cosine of 3x. This was not there. So in this case, I had to multiply by 1/3 so that when I do chain rule, this function doesn't have a 3 left over in front of the cosine. Lastly, something that always gets students is the square root. I always have my students write it to the 1/2 power, and you add a power or add 1, which is the same as adding 2 over 2. So of course that's going to become x to the 3/2, and following that shortcut rule, I multiply by the reciprocal, which is 2/3. And if you check, when you bring down your 3/2, they will all reduce to 1. And if you subtract 1, you get 1/2. And that's it, the antiderivative. You can now complete the first section of the worksheet that has been attached on Canvas.